young scientists, today we're going to host the 2020 Adhesive Olympics brought to you by GE Research. Which adhesive do you think will bring home the gold? Let's get started. First, how do things stick together? There's lots of different ways that you can stick things together. If you want to learn about some of these techniques, check out our other video titled Virtually Bonding Materials in the Kitchen. When we stick and join two things together, we usually want them to stay together. If you put a sticker on your notebook, you'll want it to stay there and not peel off. If you have a strong bond, things are going to stick for a long time. If you have a weak bond, they're going to fall apart easily. Today, we're going to learn how to measure the strength of this bond.
We measure how strong something is by breaking it, so get ready to break some stuff. Let's start by looking at how these joints can break. Then we'll build an apparatus to test them. Let's look really closely at the interface. When two surfaces are joined directly together, they can break either at the interface, which is where the two surfaces meet, or they can break in the material near the joint. If the two surfaces are joined together with a glue or an adhesive, then they can break at the interface between each surface and the adhesive, in the material next to the adhesive, in the material next to the interface, or in the adhesive itself. When you break your parts, look at where they break because that will also tell you how strong your joint is. Let's build something to measure the flexural strength, which is something we measure a lot at GE. Flexural strength is how much force a material can withstand when you're bending it before it bends or breaks. The first test we're going to look at is the 3-point bend test. First, we're going to show you an example of a material being broken at GE. The actual breaking itself is pretty fast, so keep an eye out for when the material starts to break. Did you catch that? Let's take another look at that again in slow motion.
Now we're going to show you a typical mechanical test that we use to measure materials' toughness. So what you'll need is some popsicle sticks, some different adhesives. Here we have sparkly glue, some regular glue, two different kinds of tape. You'll need some kind of either a cup and some string, a bag, or a bucket, and some kind of material that you can weigh. So in this case, we're just going to use crayons. So for the 3-point bend test, we call it a 3-point bend because there are 3 points of contact on the sample. So once you have your popsicle sticks glued together, you'll have two objects, either chairs, two tables, or some other kind of object you can rest the sample on. This provides 2 points of contact, and our third point of contact will apply pressure in the middle, and this will ultimately break the sample. So as I add each crayon, I add weight, which increases the force in the middle of the sample until eventually the sample breaks. So now that our sample broke, we can dump out the crayons and count how many crayons it took to break each sample. From this, we'll be able to find out which material sticks best.
And the results are in. Who performed the best in the 3-point bend? We'll plot this in a bar chart, where the y-axis is the number of crayons it took to break the part, and the x-axis is the adhesive, specified with thin tape, glitter glue, glue, and the 3M thick tape. The glitter glue came out on top. It receives the gold medal. In second place, the standard traditional glue gets silver. And in third place, the 3M thick tape.
We looked at the 3-point bend test, but some materials perform differently in different tests, so we want to do another one. Let's build something that measures tensile strength, which is something else we measure a lot at GE. Once again, we're going to be comparing our contestants, the thin tape, the thick tape, the glue, and the glitter glue.
To prepare your working area, I recommend placing a napkin down wherever you're going to be making these tensile test substrates, just in case you have a spill or some glue gets on your table. I also recommend gloves if you have them. They can be any sort of gloves. Make sure that they're compatible with whichever glue you're using. After that, we need some type of substrate to do the tensile tests with. So I've chosen to use a simple popsicle stick. This is like a craft style popsicle stick. And to do the tensile test, basically cut this in half so that we have 2 halves of one popsicle stick. This will allow us to basically place the adhesive between the 2 popsicle sticks and apply force in the tensile direction, hopefully separating these 2 popsicle sticks apart from one another. We're gonna test 4 adhesives today, so ideally we'll need 4 sets of these 2 halves popsicle sticks, And we want to make sure we replicate all of our samples to make sure that we are really probing the true average of what these adhesives perform. So we're going to times the amount of substrates by 3. Next, you're going to need some type of bucket. The bucket's going to be used for holding the weights that we use for the tensile test. Next, you're going to need a weight. You could use coins, you could use utensils, anything around your house that you can easily measure the mass of. I've chosen to use packs of crayons. They can be added pretty easily to the bucket. You may also wish to use a Q-tip to spread your adhesive. And you might want a marker to write what the sample name is on the tensile test substrate. Next, you're going to need your adhesives. So I've chosen to have a double-sided tape, a thicker double-sided tape, and 2 glue samples, one of which is a traditional school glue style, should dry transparent, and a glitter glue that should dry glittery. Okay, let's get started. So I've laid out 4 different sets of tensile substrates, and I've marked which type of adhesive we're going to put on each substrate. We're going to repeat this 3 times, so you may also want to indicate a sample number. I'm going to leave them blank, but you could do that if you wanted to test different conditions or if you wanted to track which sample was which. So the first one we're going to do is thin tape. We want the surfaces of these 2 tensile substrates to overlap about 2 inches. We leave about 1 inch on either side that is not covered. So what I'm going to do is take approximately 1 inch or so of tape, maybe a little bit more. Take the tape, put it on that section of my substrate, and I'm going to place the opposite end right on top. Apply a little bit of pressure and set that substrate aside. I'm going to repeat the same thing for the thick tape. Keep the distances about the same. I'll use this as a reference. Okay, so now we've done both thick tape and thin tape. Now for the glue, you're gonna want to spread it evenly. I'm just going to spread it in like a serpentine-like fashion and rub it in with a Q-tip. And place my other substrate on top. And the glue will need a little bit of time to dry. If you were to pull it now, it would have a pretty weak tensile strength. Finally, final sample is the glitter glue. This will be an interesting time to make a prediction about which of these adhesives would have the highest tensile strength. We're going to allow these samples to dry, and then we're going to tensile test them. The first one we're going to do is this thin tape sample. From the cross section, there are 2 sides. We're going to take this end and place it on a flat surface and put a weight on this side. You can use your finger or your friend's finger, and they're going to hold that down while we put on the other side basket or whatever we have that's holding the weight. As you can see, it has broke before I even added any weight. So that means the tensile strength of this thin double-sided tape is actually very weak. What we can do is look at the surface at which it broke, try to analyze which side it came off on. So it didn't come off the top, there's no tape on the top here, but there is still tape on this surface, on the bottom surface. So it looks like our thin tape is pretty poor. We'll repeat it to make sure 3 times, but it fell with just the weight of the bucket. Starting to see a little bit of failure there on the edge right here. Nothing catastrophic yet though. Held all of our crayons, meaning it has a tensile strength equal to our crayon mass. So we'll have to upgrade this to a higher mass sample. Thick tape plus the bucket and all the crayons, pretty sturdy. So we're going to have to up the weight of the thick tape. It has maximized our weight. The last one we're going to try is glitter glue. Looks like there's some separation happening. Still holding the crayons plus the basket. And failure. So now when we look at this, we can see that there's actually glue on both sides. The results are in. Which glues have better tensile strength? Let's compare the same bar graph as we did before, where the y-axis is average number of crayons and the x-axis is the adhesive type. From left to right, we have the thin tape performing the lowest. Then we have glitter glue achieving the bronze medal, the glue achieving the silver medal, and the thick tape achieving the gold medal which adhesive performed the best for you. Finally, we can also compare each adhesive in table format. Here we have a row for each adhesive and a column for the tests we performed. Depending on what you want to get out of your adhesive, you can select the best adhesive for the job. From left to right, we have the 3-point bend results, followed by the tensile test results, followed by transparency, or how much you can see through the adhesive, followed by, all the way on the right, quick application time, meaning, can I just stick this and go, or do I have to wait for it to dry? The thin tape performed poorly in both flexural and tensile tests. Maybe this tape would be suitable for projects that did not necessarily require too much strength. The thin tape may also be good for projects that require the tape to be see-through because it has some transparency. And it also may be suitable for projects that have or need a quick application time. The glitter glue is another example. It performed well in both flexural and tensile tests, but it's not see-through, and you have to wait for it to dry before you can use it. But maybe you want to do a science experiment and have glitter afterwards. The rest is up to you. Thank you for joining us for the 2020 Adhesive Olympics brought to you by GE Research. We hope you had fun joining things together, breaking them apart, and we hope you join us next time.